eMaint, a Fluke company. And thank you for joining us for this month's Best Practices webinar. And let me just take a moment to clarify the purpose of our Best Practices webinars. You know, as software providers of CMMS software and other tools, we do offer quite a wide array of educational offerings and product trainings. But on our Best Practices webinars, we don't focus really on specific software, but really on the maintenance strategies that help organizations really achieve the maximum benefit from their maintenance activities. And so we invite a variety of different speakers to come and share their knowledge. And I'm pleased to have with me today a new speaker, and he's a member of our team, Scott Rojas, who is with us today. He's a certified reliability leader and a member of the eMaint account executive team. And he's going to be presenting today's topics on setting up a framework so that you can realize cost reductions with your CMMS through a risk-centered approach. So thank you, Scott, for joining us today. And while we give people a minute to log in, maybe, Scott, you can tell us a little bit. I know it's the first time you're doing this presentation, but you've had quite a diverse background. You talk to so many clients, prospective clients who share their challenges, and you're a certified reliability leader. And what sort of inspired you to put together this particular slide deck that you'll be sharing today?
Good, yeah. Rona, I think the biggest thing as an account executive here for eMaint that I encounter are people in early stages of looking at CMMS. Very often they are in a reactive state. They are trying to make a business case. And so in doing so, there are some major challenges there, but the focus tends to be, and I've discussed this before on some other podcasts and things that I've done, is the focus tends to be on the features and functionality of the software, which is certainly has to facilitate the program of maintenance and reliability, but the implementation, the approach, the culture of the organization, these are things that must be in place to really get that ROI. So the return on investment really comes from the approach as opposed to the features themselves. How do we apply the tool that is CMMS in getting the returns and what is expected out of assets?
Excellent. And I understand that this can be really applied to wherever you are in the journey, right? To any CMMS, or whether you're considering implementing or already have an implementation that you want to improve upon. So I'm looking forward to it. All right, well, before I just turn things over to Scott to get rolling, let me just go over a couple of quick housekeeping items. We are recording this presentation. Scott has really assembled quite a wealth of resource materials. So we'll be recording this so that you can view it or share it with your team at a later time. We'll also share a PDF of the slide deck. We'll make that available because there really is some good source material here for reference. And you'll just have to request it at the end. There'll be a survey at the end of the presentation. All right, and also Scott has agreed to answer any questions you might have and stay through the full hour if needed. So you can type your questions at any time in the questions feature in GoToWebinar, and then I will read them to Scott where appropriate or at the end of the presentation. All right, so without further ado, Scott, let me turn it over to you.
All right, thanks, Rona. Appreciate that. So I'm excited to be here. Thank you for inviting me on this webinar, and let's cover some of the things or just get a little overview of what we'll be talking about here. We're really going to start up high and then come down to the floor. So we're going to look at a high-level overview of essentially what Rona was describing as a framework for getting the cost benefit from your CMMS system, and really we're going to start with the origin purpose of asset management and risk management, and then we'll go through some other topics like RAMs. We'll go through where the CMMS fits in all of this, and then a very complex subject, chronic failure analysis, which really addresses failure modes, and a little bit about metrics and how you can use what you already know to come up with good metrics. And then we'll wrap it up with the Q&A and questions. So let's go ahead into the first slide, and it's our poll. Ronnie, do you want to pick up the poll there? Okay, so I'm not hearing, usually Rona will take over the poll at this point. So,
Oh, I apologize that I was on mute. My apologies. But I did close the poll now and share it, and it looks like, Scott, almost half of the people, half of our audience don't currently use the CMMS. So they're here to learn what's possible. Under 20%, that's 30% of our audience. 15% are saying that they've achieved between 20 and 40%, which is quite exceptional. 6% say they've achieved between 40 and 60, and we did say there's 1% of the audience has achieved greater than 60%.
okay, so yep, a variety there to be expected. And I think one of the points is that in order to really get this information, right, we're utilizing the CMMS to get the metrics that are necessary. You know, obviously we have to have the measures in place. So just even a starting point of folks knowing how to answer those questions, you know, whether it be B, C, D, or E, tells us that there are people measuring, which is the important part of this here. So, and those things and some of these, like for example, greater than 60%, you know, that can take well over 5 years to really accomplish. So congratulations to that. So just go here, next slide. So I'm going to just start where this is really coming from, and this is not coming from me really. So it's really coming from standards. International standards were put in place at times, you know, when there was crisis, and you know, for industries, and really the adopters of these standards are going to be high reliability and high risk industries, really where public risk or there's a custodial relationship. You know, the owners of the assets might be really the public, and the organization that has you know, the care of the assets are stewards of those public assets. So I call these high reliability industries. They might be aerospace, military, water treatment plants, and municipality, energy, mining, oil and gas. And really the risks are high, but the rewards can be too as well. So when putting these standards together, you know, this is really the foundation of cost reductions that are possible. And so what the point here with the ISO 55001 and ISO 31000 is, it's focused on risk and understanding consequences in terms of getting value out of assets. So Asset management, it's really, let's define it, and this is a cultural view. If you think about it, it's coordinated activity, or ISO 55000, the document. It's coordinated activity of an organization to realize value from assets. And they go on to say that it's really a balance of costs, opportunities, and risks against the desired performance of assets to achieve organizational objectives. So the themes throughout this presentation are going to be sourced at some of these first slides that I'm showing here. Also, assets exist to provide value to the organization and its stakeholders. And so the key point here to take away from this slide is that asset management doesn't focus on the asset itself, what the asset is, but really on what the value of that asset is and how it could be provided to the stakeholders and to the organization to realize objectives. Now, the other thing, it includes there that the establishment of decision-making processes there on the bottom that reflect stakeholder need and define value. This assumes that data must be available. So it's a very important part of where the CMMS ties into an asset management system or risk-based approach. So ISO 3100, the thing I really want you to get out of this is 2.1 there and a couple notes. And keep this in mind as we're going through this presentation. So I'm going to talk a little bit about about maintenance and where it sort of fits in there and some connotations of it. But think about this: risk is the effect of uncertainty on objectives. And then I would note, this is important to take away. Some of what we're going to talk about is a reliability-centered maintenance approach, or some of the elements of it. And so we talk about events and consequences. These are really going to get the actions of stakeholders. In other words, something matters to stakeholders and they take action. And some of the events might be the effects of failure, for example. So really it's about managing risk of failure, which is a threat to the objectives of an organization. So essentially, it's really a shift in consciousness. So when stakeholders are looking at it as an ecosystem of continuous improvement, when they understand that they contribute to the challenges and the limitations placed on assets, their role in responsibility in that process makes them responsible. So think of this kind of like a good safety culture, right? Everyone knows that throughout the organization, safety is everybody's responsibility. It's not the maintenance department, right? That doesn't fall into the maintenance department. It falls into everybody's department. So this is a shift in, essentially, in asset management, it's a shift in thinking. Also, we look at the threats based on failures and consequences that affect the stakeholders, and so they're more likely to really become personally interested to protect and preserve asset health. And so a lot of what we're going to focus on here is preserving and protecting asset health. And then ultimately, if you think about safety culture, there are certain things that are just not tolerated, and that's how the culture really needs to change in terms of what are the threats to our objectives. It must be looked at in terms of priority, but also a measured sort of intolerance for some of these threats and that originate from failures and causes. So here's where I wanted to talk about the kind of the culture or the idea about maintenance in general. So, maintenance, and this is me now, so really it's the mastery and of the art of leveraging tools or technology to effectively execute strategies via processes to manage uncertainty or risk in a continually changing environment. As we know, things change, so maintenance sort of has to be doing a little bit of Tai Chi here in terms of what is being expected of the assets. So this is important. And I wanted to point out one of the things and some of the connotations of maintenance during the reliability conference. Alan Catchmore talked a little bit about what, common sort of myths about maintenance, and he mentions a few of these things that we really have to debunk here. So he talked about, through maintenance, you can achieve reliability. more maintenance being done is more reliable. Think about that for a second. Not really, right? Because we could be reacting to issues and repeating them over. And we're going to talk about chronic failure analysis. Critical assets really require more maintenance. No, that's not so. In fact, hopefully less. And really, maintenance is a necessary evil, and maintenance is a service to operations. That's a big one there. So no, that isn't so. So hopefully we can get everybody working together. So decisions are made, right? So the organization has objectives, and they're looking at what do we want, what is our context in the world, in the community, and what do our shareholders want, and they make decisions specifically about the asset portfolio. And so they'll go over in order, requirements. They're looking at, well, what kind of value can we get out of the assets when they're looking at vendors, and so what they'll do is they'll draft some engineering designs and look at the risk tolerance of the organization, and then setting expectations about performance standards, and then budgeting, obviously. Hopefully this is being done, but budgeting for capital and operating expenses, including disposable assets. And in some industries, that's a huge thing. Think of the nuclear industry, for example. Now, I'm going somewhere with this. Essentially, and this is taken from a lot of different sources, but 80% of total asset lifecycle costs that are primarily occurring during the operation and maintenance phase of an asset's life cycle are determined really at the initial stage where the specifications, engineering, design, and implementation happens, installation rather. So thinking about this for a moment, you have essentially one chance to really get it right when you're going to make some of these decisions about the asset portfolio that's going to affect things like maintainability. So obviously those are some things to think about. So the organization context and then operating context. So essentially the organization context, it's the environment, if you think about internal and external stakeholders, and what value they derive from the assets. And then for assets, it's what is the context, and it's how it's functioning today at this very moment, and how do we keep that sustainable. So there's also the functional location of assets to differentiate, the asset itself. And so, for example, if you have a Ford truck in an Alaskan winter versus a Ford truck on Route 15 in Rancho Cucamonga, California, two different contexts, right? And so those contexts can also change as well. Now that point is going to be important in the process, really centered around reliability-centered maintenance and some of the things that we're going to look at today for chronic failure analysis. So it's really going to be important that these initiatives, really, the underlying initiatives have sponsorship, there's investment, there's enablement for decision-making throughout different leaders in the organization, and then asset management directors are really to be clear. It's a mindset, and you kind of set it like a diamond and firm and nice and beautiful, but it really has to come from top management. So that's what this slide is talking about here. And so executive sponsorship really establishes the attitude of the organization. So if you think about attitude, it's in terms of the direction of the organization, so that you can elicit the right thinking and behaviors. And so executive sponsorship should really encourage natural leadership and communication at all levels, and not giving preference to departments. This is really an ecosystem. So RAMs. So what RAMs really describes is reliability, availability, maintainability, and safety of the asset in question. So I mentioned before that 80% of the total life cycle costs are really determined early on. That especially affects maintainability, and maybe I'll give you an example later of some of the issues that I've seen around that. So some of those early decisions. But what are we really trying to do? We are the end all and be all of asset health, and life is really those four domains. So everything that the asset management should accomplish at the plant level should strive to maximize these four asset domains. So it starts from the concept of what does the asset need to do, to the design, build, placement, onto the operational phase of the asset's life. and that goes back to the martial arts of maintenance. So I'm going to talk a little bit here about sort of the top down. So we have our asset management plans. We're looking at risk to objectives of the organization, where reliability, availability, maintainability, and safety fits into that. And then we have from that the inherent capability of the asset itself. So in other words, if you don't do any redesign, you can't expect to get more out of the asset. And then the goal really in the maintenance and reliability world is to preserve asset functions. And then it boils down to how do you do that? You do it by managing risks. So there's our cloud. And we'll go from this cloud here into a little bit more detail. So how does this look? We have the CMMS here. You have your CMMS, you have transaction data, which is essentially the day-to-day asset management activities, and then you have your CMMS, your data foundation. So the goal here, in order to manage risk, is to use essentially an ecosystem where the maintenance function includes reliability, and there's some review going on around chronic failure analysis, but you see that at times, depending on different levels of cause and different consequences, this could involve operations and maintenance leaders, engineering, EHS, and definitely executives. So we'll do a management by exception for any really high criticality failures and do things like root cause analysis and risk-based assessments around that. What that essentially ties into over there on the left are really the criticality, the strategies, job plans, technology, and training. Those things are put into place in order to facilitate making sure that this issue never happens again, and we're managing risk. So one thing I want to point out, so essential business technology, CMMS's role. So, companies have accounting systems. Well, if you are an asset-dependent organization, you certainly a CMMS is an essential piece to this. So this is kind of 4 pillars here, essentially, of the organization and where CMMS fits there down on the bottom right. So you have your stakeholders, and really they're defining the risks, the opportunities of the organization, which drives the standards, may review documentation or create documentation in terms of what are the policies going to be, and really make informed decisions based on what happens. Creating the processes, it's just how we run, how we operate, and then producing documentation for that in order to make sure that we're following job plans, for example, and then using the CMMS system, really leveraging the technology. And what I really want to point out here, and I like to get into this discussion briefly when I'm working with clients, is that the processes are the system. Here I want to empower the customer to realize that you guys have the system. You understand what's going to work for your business. It's one of the reasons why a CMMS system really has to be configured according to what the system is and what you view the system should be. And then it's software. So what it is a platform. Right? It's a software platform for your system, and that's the point here. And then we have some technologies like AI and machine learning that help with finding, and we'll go through some of the other concepts when we get down further, but we'll talk a little bit about the PF curve there. And that's kind of where that ties in. And this is kind of a newer technology, right? So machine learning, responding back to some of the things automatically that can help keep assets in good health. If we went a little bit deeper into really, a lot of folks will say, hey, we need a work order system in asset management. I get that a lot. So what the point of this slide is really creating a living program. And it's a process. So those who answered on the poll, for example, that they're up to like 40 to 60% reduction in cost after implementing the CMMS system, that doesn't happen by accident. And actually, most of the CMMS implementations, maybe about 50 to 80% of organizations that implement them actually fail, and that leads to a lot of misgivings about CMMS and some of the initiatives like reliability-centered maintenance. So we're on to our next poll question. Rona, you want to take it over there?
Yes, and I have unmuted myself. Sorry about that earlier, guys. So right now, Scott would like to know, what's the basis of your current program or your most recent program? as far as preventive maintenance. You can either say we don't perform any preventive maintenance, or you have generic maintenance strategies, or you have documented recommendations from the OEM, or you build work plans and a library of tasks, or you might have a team that periodically performs risk-based assessments. So again, this is sort of a continuum, and let us know where you are as far as the evolution of your PM program journey. All right, it looks like we have about 2/3 of the votes in, so let me give people a few more moments here, and then we'll go ahead and share results. Okay, so Scott, it looks like 5% are saying they currently don't perform any preventive maintenance. They must be in run to failure mode. 36%, over a third, deploy generic maintenance strategies, depending on the asset. 32%, close second, say they follow the recommendations of the vendor. 24%, about a quarter, say they use their judgment and build work plans and have task libraries. And then 4% say there's a team that performs risk-based assessments. All right, so that's where we're at, and back to you.
All right, thank you, Rona. So, yep, with not performing any PMs, essentially you have one extreme there where the organization probably can't even get to them. So we're going to talk about a few different levels here as we go through this, but essentially if you're not performing preventive maintenance, that may not be bad, because in fact you can't really perform preventive maintenance on assets that are continually failing, because you have to get them restored first, and it's pointless to do PMs on assets that are constantly failing, right? So there has to be a restore point, and we're going to look at essentially what are the consequences here, and what are the risks surrounding that particular asset. Is it something that we really should be performing preventive maintenance or worry about? And on the other hand, it's a lot of the organizations will be in the C or sort of B and C section, where it's really, we just do a bunch of stuff and kind of hope it works, and that could be really costly, and that's where the popularity of condition monitoring programs have come in. And really where you want to try to get to is performing maintenance based on risk-based assessments. So I'm going to move on, and let's talk a little bit here. I'm going to go through plant cost reductions, because that is really where we're driving at. So we're looking at what's attainable. So different scenarios here is if going this journey, so to speak, and we went from A to D in those slides, you have kind of a progressive approach towards world-class reliability. And gosh, I mean, it will take organizations quite a long time to get there, but that's okay, because the results are really cumulative. So what we're looking at here is year 1, year 2, year 3, year 4, 5, implementing a system, and these are some attainable results. In a scenario 1, no actions deployed over the course of 5 years, you're looking at a cumulative maintenance cost for 5 years of $7.5 million in this case. And we could be looking at an organization here that has 4 or 5 really maintenance folks that are going around and performing a lot of reactive work, high costs and inventory and so on and so forth. And then in scenario 2, following a sort of a risk-centered asset management approach, the total cumulative maintenance cost over the 5 years is approximately $4.75 million, and those are closer to world-class results. Now, we can't expect to get there in 5 years, but you can see a drastic difference in terms of yearly costs or annualized costs. Now, if you accumulate that over 5 years and year 1 not doing anything for both organizations, you're looking at a difference in $2.27 million in this particular example. So you know, with the progressive application of the strategies and practices and principles that follow in the next slides, organizations can yield significant cost reductions. So that's what this is all about. Now, if we look at year one, we look at, you know, things like we're in a state of, and so this might be hard to see on the screen, but your starting state of maintenance and reliability is very reactive. It's ineffective. There's an application of maintenance that's not really getting anywhere, a lot of reactive maintenance, low PM compliance, of course, because you're doing reactive work. There's really a high cost to labor effectiveness, a lot of overtime, huge backlog, high cost of materials, and really missing the mark on the return on assets. And as you go into a risk-centered maintenance and reliability strategy, now in year two, you could start looking forward to, you know, a proactive culture, using chronic failure analysis to focus on bad actors and worst offenders, getting those identified. During that process, you're performing RCA's, failure modes and effects analysis. Asset criticality is documented within the system. In other words, your PM program is really addressing failure modes and what really matters, not everything. And really, the cost reductions are going to be offset, though, by probably putting in a reliability engineer and the CMMS implementation. Now, as you move further into maturity, year three, we're looking at an increased effectiveness. You have a higher PM compliance. You know, failure finding tasks are regular because you have the time to actually do that. You are addressing failure modes, and that is the basis of your PM program. And the CMMS is a living program within your strategies that you're using. So you're getting the data from that. You start looking at optimizing PMs. You're getting your backlog in check, and your inventory relevancy to failure modes is there as well. So again, we're looking at the failure risk, and using the inventory more of as an insurance policy. That's the way I think of inventory, and you guys can call me out on this, but I think of inventory that you're going to have in stock is really insurance. And then some defect elimination. In other words, going to the source of defects and looking at perhaps re-engineering it and redesigning it and rebuilding it and restoring it to a better condition. Year four, you're looking at really maturing. You're deploying predictive maintenance technologies. They're definitely reduced PM work because of that, so you get a significant change or saving there. You're looking at more management decisions from a data-driven approach, definitely more focus on defect elimination, capital improvements, and now shutdown turnarounds and outages. And you're looking at your cost reductions, though, in this particular year, and again, this is just an example, but is probably going to be offset by condition monitoring technology and other capital improvement projects for that defect elimination. And then year five, you're really looking in the precision maintenance culture, operator-driven reliability, TPM, you know, and major defects have already been eliminated for the most part, and you're functioning on high with operational excellence. Definitely more is available for capital reinvestment, and so that significantly increases profitability. Now, you can break this down to year one to year five. That may not be practical within your organization. This could be year 1 to year 15, year 1 to year 10. The point here is that it does have a cumulative effect, and you are working towards continuous improvement. You're also just getting that benefit of the approach itself and being more effective as an organization in terms of what your product is or what it is you're delivering, and it just feels good. So we talk a little bit, and we're going to get a little bit more into the risks and the things that are sort of put onto assets. You know, we have an expectation of how it's going to perform. So initially, maybe a company made a decision about, and I like to use this example here with the van and the bus. I mean, if you look at the van, that might be good for a Ford dealership that's, you know, carting around 2 or 3 people, you know, for doing maintenance work on their car, you know, regular scheduled maintenance on their car, and they want to get them to work, that sort of thing. And this would be a good asset for that, but might not really work for the airport. So you might have another company look at, well, let's look at an asset. And so what the point here is they have some standard of performance of an asset, and they state what that standard is, and then the whole idea is to maintain that standard. In other words, protect the assets function, which in this case seats 21 passengers for a short distance. Now, when we're talking about assets like motors and pumps and compressors and things like that, generally what happens is that initial capability, they sort of compensate for it, right? There's a margin for deterioration. That's normal. We'll look at the PF curve again, and then we'll look at the line of desired performance. But what happens very often here, and what I want to point out, is that very often the stakeholders will actually raise that bar, and that's where we can get into some significant trouble, where we might have to evaluate what the risks and threats are because of that. And that goes back to the culture that I was talking about. So asset criticality, and we talk about creating a living program in the software, and the whole idea of asset criticality is to apply the Pareto principle here and really focus in on the causes, right? Get to the root cause of issues where it matters. That's the most important part of this. We look at what is affecting the objectives of the organization. This is why I wanted to bring in risk and also asset management. It's all about what value do we get from the asset? What is the risk to our objectives? And so asset criticality focuses the maintenance and reliability program on exactly how we're going to, or where we're going to apply our resources, and that's where the 80-20 rule applies, because generally what we find is that 80% of the problems or issues are coming from only 20% of the assets. So we have to get the data, figure out where exactly we need to focus our programs. So we'll talk about asset criticality, asset taxonomy, and then functional location. So functional location is interesting. There's a lot of confusion around functional location, but essentially, if you look at that pickup truck there, I think it's a Nissan pickup truck, right? If you think about what normally goes there, right? It's not there, and then they took this hand cart and they threw it in there. Well, the functional location is that spot where the wheel and tire should be to spec, right? So, and they decided, let's wheel this thing in. So they took this asset and they put it in a functional location that really probably can't be sustainable. So these are things to consider, not just the asset itself, but what is the context is I think what I'm driving at here. What is the context that the asset's being used? This is of huge importance. So asset hierarchy and failure mode. So what are we trying to do with this? We're really just trying to get down to the component level and find out the failure modes, or what are the likely failure modes. So we might perform a failure modes and an effects analysis. We might perform other risk-based assessments and find out, where are the points of failure. And what we're driving at here is the component level. And I'm going to go into failure modes in a moment to describe that. So we have different, from that, we're going to come up with our PM program. We're going to come up with our strategies. We're going to come up with, well, how are we going to address these failure modes? So now your different options, this comes from project management. I mean, I'm sure a lot of you have seen this before, but you can accept the risk. Light bulb goes out, that's okay. Light bulb goes out, no problem. What's the context? Let's go back to context. Light bulb goes out, operator loses arm because he didn't see something. Different context, so it's not risk that we're willing to accept. Avoiding risk, you can transfer risk and you can mitigate risk, which is mostly what people do. The whole idea really is the approach is going to be based on what's technically feasible and also worth doing or cost effective. So failure modes, very simply, what is a failure mode and where are we getting our Pareto analysis from? Failure mode is an object. It's the problem that essentially is noticed, and then what are the different levels of causes as necessary. So I have levels of causation down there, and this comes from SAE-JA 1012, which is a guidance document for reliability-centered maintenance. So if you look there, for example, you have an impeller, which is the failed component. The component problem comes adrift, and then you always say due to, right, impeller nut cracked. And then if you need to go to another level of causation, you go down to impeller nut was over tightened, and then due to wrong material specified, or due to training issue. The point here are two. we have to decide what is the level of causation that's really applicable. But the most important point, and this ties back into the CMMS, is that the CMMS must use validated form fields on electronic work orders to capture this information, because the reliability engineer is not going to be able to go through gobs and gobs of text in order to get this information. So essentially, it's finding exactly where the issues are, what the failed components are, so we can address them and not having to go through a lot of different hunting. So we look at failure modes, consequences, and corrective actions. Talking here about the RCM process. Really what you're looking at is establishing what are the consequences. In other words, is it worth doing? We'll have to know based on what the consequences are. What are the effects? What is noticed? And this really depends on the, at the moment that a work order is issued, what exactly was noticed? What are the things? Now on the work order, this might be text, right? You might say, well, here's what sort of happened, but the failure mode should be a validated field, and then we come up with some corrective action based on what the operating context of the asset is, and we're talking about the component level here. So we're going to look at the performance standards, but focus on the consequences as to what our corrective action should be. There are different types of consequences, and they'll have an order of priority: safety consequences, environmental, operating consequences, and non-operational consequences. Just a little bit about failure modes and validation within the work order system. This comes from JA 1012, and this one here is essentially what we described earlier. So you have your component problem, and then the levels of causation. In this case, we could have validated fields for levels of causation starting around 5, 6, and 7 there on this particular chart. Point is, let's get that into the CMMS system so we can drive to the sources and figure out what are really the problem worst offenders. So what happens after this? You're capturing the data in the CMMS system through via transactional data, right? The work order form. All that's going along with that is obviously inventory and all the things that need to support it. Inventory being essentially insurance, sort of insurance for your PM program and for your critical spares. And then there's a review going on, and through that review process we come up with the strategies and the job plans that are going to address the risk or failure modes. So performing chronic failure analysis is a little bit more detail in that. We're just looking for the worst offenders, and it's really going to be based on the organizational impact. Some of that might be focused on return on assets, and other situations it might be more about safety and environmental concerns or regulatory concerns. So we can look at different consequences here and do different Pareto analysis, and so commonly it's going to be, what is this asset costing me? So what do we really need to know about failure? We need to know about severity. So this is sort of a review. Why does it matter? What is the context it's being used? Probability of occurrence, and the whole goal here is, what are the inputs that we're going to need to determine this? So we're going to do some sort of metric to be able to really hone in on exactly what the probability of these things to occur are. We're going to need some data on the work order. The effects, predictability, patterns, and then the output. Really, what is the strategy? And again, it boils down to accept risk. Is it a run to failure? Is it avoiding risk? Do we remove the defect? Again, what is the consequence? How important is that? What is the impact? Transferring risk, assigning the function to maybe another reliable asset, or mitigating risk. And that's mostly what people do, and that's okay. That's probably the most cost-effective solution. So as far as inventory, our parts inventory, the way I look at inventory is it's an insurance against risk. So I get a lot of this, yeah, we kind of do it by eye, or well, most people don't play it by ear because they can't hear their inventory. But the point here is that inventory really is an insurance against uncertainty. And think about insurance for a second. You don't want to overbuy your insurance, because if you do, there goes your profit. So we all probably seen stuff in our garage that's inventory that essentially has no value today. And then obviously, and one of the major points here too is having the inventory on hand for the threat or the risks. Think about this. Are you going to replace the major component once damage is already done? That's going to be extremely costly, or is there a part we can replace, or was the cause have something to do with lubrication? And by the way, what is the appropriate interval? And this is what chronic failure analysis should be answering those questions using things like mean time between failures and Weibull analysis. And then how to really use the point here, underlying or overarching, however you look at it, really is that you're using the inventory to address failure modes, and that must really be detailed in the job plan. So how are you going to do it? How is this inventory going to be applied, or these parts? So we talk about the PF curve here, so where the detection happens. Again, back to the effects. What is the earliest evidence that we have to detect the failure, and how can we use technology? So more than the sense of touch or smell, or it kind of seems, or do it by eye or play it by ear. Why don't we look at different technologies really to apply here to have a cost-effective strategy? And then so how do we leverage the CMMS really to take action? And so what we're going to do is we're going to perform effective planning and scheduling of operational and non-operational corrective work for minimal downtime. What that means is you don't want to perform during operations time, you don't want to perform a PM that's labeled operational, right? Because that'll stop the production, or it'll stop when the asset is actually needed. So you do it during non-operational times, or a non-operational PM. Establishing a failure management policy. Really what you're doing here is determining what the PM tasks are, what the stock levels need to be. Your whole idea there is to control downtime. It is necessary, but it can be controlled by effective scheduling and procedures for an expedient turnaround. Inventory management, really, again, insurance against risk, making sure that you have the right coverage, condition monitoring, TPM and ODR, and asset investment decisions are really asset lifecycle management policies and choices, and then just about everything that really stakeholders should do in an asset dependent organization is determined by the failure management policy. So where do we get the data from? So point here is you have a better idea, better than I do, when somebody comes to me and says, we need to know, what mean time between failure is, or we need this data. That's fine, but really what's keeping you up at night? So the whole idea and where to start with implementation is start with what's keeping you up at night. Those are going to drive the answers in terms, or the questions, the metrics that you should be getting in order to apply to your particular situation, depending on what your objectives are. So some of these things, the questions that asked the night before, what is the probability? These are some of the things. How often? Why does it happen? How much? How can we tell? So the answers to those questions are the whole idea here is to configure the work order to be able to answer these questions and drive the data to get those answers. So here's some select few. There's tons of different metrics, but what we're going after here is world-class benchmarks. That's kind of what we're driving at. Plan for perfection, or at least try for perfection and get excellence. So here's some metrics. You're going to have this slide deck, so certainly look through some of these typical metrics. But these are metrics driven by some of those questions that are asked. So essentially, we're just about done here. Whole idea really, looking at this from a risk-based approach, you get the benefits out of, you get the financial benefits out of it, and maintenance is not just a department that is really there to kind of clean up messes. It's really there to manage risk. Goes back to that cloud that I showed you. So just some select sources of information. There's lots of them. These are some of the common places where I find a lot of the information that helps me in my journey to learn more and know more. And I hope you've enjoyed the presentation, and we have a little bit of time for questions, just about 10 minutes or so, and I really wanted to get to that. So Rona, why don't you go ahead and take over with the questions.
Excellent. Well, we've had many come in, and if we can't get to them all, we will promise that we'll share them with the team, and either Scott or someone on the team will get back to you. But when you're talking about information and the metrics, some people asked about OEE and others asked about MTBF. And can you speak to the importance of those and how you leverage a CMMS to get those kind of measures and why they're important?
Yeah, so think about mean time between failure, and not everybody will agree as to whether that is a valid metric. There's definitely, a lot of folks will say, well, it doesn't really give you the information that you need. And this is what I say to that. What I say to that is use a combination of metrics in order to get the bigger picture. Not one metric by itself will tell the entire story. So when you're combining the OEE, and the mean time between failure, you can get a little bit of a better picture together, for example. Now for OEE, what is the availability? That really speaks to the availability, how much is the asset running or available to be running, how effective it is essentially in producing. And those are metrics that are, especially, if you go back to one of the earlier slides here over in the technology section, those are really done really well by an MES system and other systems. But you can combine the information in your CMMS about mean time between failure. In other words, what is the threat level of or what is the risk here and what is causing that? So that could be a number of factors. There could be operational error. There could be wrong specified or some sort of driver that is that's causing the issue. And there's a lot of ways that you can measure, but I think that mean time between failure is kind of a good starting point in terms of building a PM program. In other words, what are the intervals going to be? OEE, there's a variety of different ways to measure OEE, and it's how granular do you want to get? Because at some point you have to document in the CMMS the different phases in terms of the asset itself. So what is, is it available? It's not down. It's available for production. So how do we in the CMMS system, how do we document that and timestamp it? You can always timestamp things in this CMMS, but are you willing to have the operator go in there and all the different cycles, entering that information in the CMMS? So there's a challenge there with OEE when it comes to with a CMMS system alone.
Right. And, it's interesting at the Accelerate conference that I know you're able to attend as well, that we just held last week. We heard from a couple of clients who are, Poly One uses OEE as one of their key metrics to remain, and NEFCO, the other presenter, also uses MTBF and kind of benchmarks the different plants against it. So for that one particular listener, we can get some additional technical information to you after this call. We also had someone reach out about vibration analysis and how that's going to be used, and I know that's going to be the topic of our next best practices presentation, but do you have anything to add to that about how getting predictive technologies figure into this equation?
Yeah, so vibration analysis is a little bit higher there earlier on in terms of detection. Vibration in a motor, for example, will be higher in order, if you can find vibration early using that technology, you're going to save a lot of the ancillary damage that can be done to the asset, to the bearing, to the housing. And a lot of the vibration obviously comes from, either misalignment, soft foot in different situations regarding the mounting of that particular asset. It could come from the shaft itself, but the vibration analysis is a heck of a lot better than me sort of estimating how it's vibrating. It seems like it's vibrating a little bit more than it was yesterday. You're probably not going to catch it. But the key to get out of this is what is the benchmark? In other words, at what point do we step in? And with any of the predictive maintenance technologies, the goal is to catch something well in advance so that it could be properly scheduled and the corrective action can be taken. So with all the condition monitoring pieces, that is really the goal, is to use the technology early, long before there's any kind of way before there's functional failure, to actually get a corrective action going, and it allows you the time to be able to plan and schedule that, so that you don't have that final moment of, all right, it's functionally failing. Now the production process, for example, is producing bad widgets, or we've done some damage to the equipment because there was a belt that was belt was sort of misaligned, right? So vibration analysis is definitely going to be good for corrective action.
By the way, we've had several people ask if we would share a copy of the presentation, and we will do that along with the recording once it's available. We'll share that with all our listeners who can refer back to it. Here's a question from someone who's been with us. I actually recognize this person. We did a case study many years ago, and they've been using a CMMS and really have had a program going for a while, and using motor testing, and really have done such a good job saving money, and their PM program is 85% compliant. But what seems to have been lost is optimizing. I guess the company has now felt it's at a plateau, and they sort of lost the momentum in reassessing the PMs themselves, and they were just sort of satisfied with the amount saved. So do you have any ideas on how to get management excited about returning to continuously improve and optimize PMs?
Yeah, so I'm not sure if the question is leading to how do we look at other technologies or invest in technologies in order to get management or leadership looking at this for, maybe investment in condition monitoring technologies. But I think it really boils down to the fundamentals. Essentially, how do we improve our PM program? See, a lot of the PMs that are done are not addressing real failure modes in the context that the asset is being used, and that's a key. So what is the context of the asset? Is it something that are we applying the right strategy? Because we all know we have very limited resources, right? We have limited people that can get around to do the rounds for PMs. And it really just boils down to noun, verb, and adjectives, really. When you're doing your job plans, really just focusing on, what is the object, what is the issue that we have, how are we going to apply a task that, look at the specifications. So a lot of times PM programs will have something like, Tighten, right? Tighten to what torque, for example. We might want to look at optimizing things just in our job plan. So you're sitting home at night and you're looking at, well, why did this, despite doing PMs, why did we have a failure? Or so you could look at things like that without having to go to leadership outside of the maintenance organization in order to make big impact. Get back to the basics in terms of, what is the impact? Is it worth even looking at any further? In other words, if the 80% is the highest we can get, that might be because we don't really need to be focused on some of these PMs that we're doing, or maybe we need to change the intervals so that we're available for other things. But basically, if you can say that you're not a reactive organization, you can always optimize, and that really boils down to what failure mode are we addressing and what is the risk against the objective.
Great. Okay, I think we might have time for one other question. Gosh, there are so many. Somebody asked about prioritization of work. They were saying, like, one might have a lot of PMs against it, but it's less important to production. Another one can cause a production loss. Can you just share again, some tips on most effective ways to prioritize work?
Yeah, it's a good question. And again, the answer still drives to the source or risk against what are the objectives of the organization. The priority comes from what are the consequences, right? We're not able to produce something. What are the consequences of that? That's where the priority really comes from. In our own lives, if we look at things, we're really motivated by consequences when we feel like we don't have any time, and then suddenly when that consequence happens and it's impactful enough, we do something about it. And so it's the same thing with the priority on your PMs. The failure modes that have the greatest risk in terms of what the organization objectives are is where the focus really needs to be. And a lot of this comes from a new version of RCM called RCM3 by Aladon. And if you look at that and you take that approach, and a lot of these concepts are fit into that sort of RCM framework, you're going to find that you're going to have the answers yourselves. The questions are so simple. What is the impact? What is the consequence? And that is how you're going to prioritize your work. What is the risk to objectives? Who does that affect? How does that affect them? Because if it affects somebody in the organization, you can quantify even the consequences in dollars, perhaps. We talked about, or you mentioned production on that question. Then it's going to have an impact to somebody. It could be the CFO of the organization. It could be the CEO. That's where you say, here's where we need to prioritize. But again, everyone really needs to be aligned in terms of what are the objectives of the organization, and then the stakeholders themselves have their own sort of objectives, and that's why alignment is so important, and executive sponsorship is important. Because if you need executive sponsorship to be able to have the investment and resources in order to, maybe it's a hiring opportunity. Maybe we need, maybe we do need that one other person. The whole idea of the CMMS is really to get to the data to answer those questions. But again, priority comes from consequence.
Great. Well, we have so many more questions, but I'm sorry, I want to be respectful of our time here. But what I will promise is that we will share the questions with our internal team and make sure that people get answers back to you. We do have whole other recorded webinars, lots of documentation on asset criticality. All of these questions are a topic unto themselves.
Yes.
So thank you, Scott, for really condensing, really taking such a broad breadth of information and putting together, within an hour. It was a very worthwhile effort and a lot of great source material. So thanks to all our listeners, and there will be a brief survey when I end the webinar, and please let us know what other topics we can bring you, what other questions you'd like answered, so that these sessions are meaningful to you. So again, thanks to Scott, and thanks to all our listeners for hanging in there, and we'll see you all the next time. Have a great day.
Thank you.